this thing down there? Let's refresh.
So group meeting quiz. Man, these need to be due on Saturday.
I tell you, man, like this midweek thing, I'm not feeling it at all.
No, me neither.
You got that awkward Tuesday, and then Wednesday, then Thursday, you got one more. So it's just.
Yeah. We should. Last week was the exam, so we should meet again on Saturday and try and get the next week's all done.
Okay.
How'd you do on your exam?
Oh, I did horrible. I lost a letter grade.
Oh yeah.
Yeah, I don't do well when like I have somewhere to go and I'm trying, like, kind of like if I have a pending task and I'm doing an exam, like I've never, almost, even if it's like an easy exam, I end up making silly mistakes. And that's what happened. I had trouble interpreting because I was in a hurry to be somewhere that wasn't even important at all, but because I wanted to be there, I couldn't focus and get it done. So yeah, I really wrecked the exam. It was terrible.
I'm sorry to hear that. I did okay. I think I got a mid B on it.
Oh, nice. It was weird to see how much things from the first exam that came through.
Yeah. Yeah, that's pretty weird, huh? So, let's see. Utility?
Okay.
So I'm looking at number 1 or
Okay.
3. The symbol for the true population portion is which of the following? Isn't that p hat?
Yep.
I thought. So the second one.
Requirement for constructing a confidence interval.
Suppose n equals 100, p equals 0.25, and p hat equals 0.1. The requirements for constructing a confidence interval are satisfied.
All right, I always have to like refer to the notes line because this is where I end up getting messed up, is interpreting it into a normal English sentence and then getting the answer. That's end up messing with me, so I like to review.
I found what's really, I understand that, I get it. It's hard for me too. I found that the remember portions of the summary at the end of the chapter is very helpful.
Oh.
So like the answer is right there at the summary. The requirements for a confidence interval are NP hat is greater than or equal to 10. And N parentheses 1 minus P is greater than or equal to 10.
Yeah. So, but P in this case is 0.25. So this will be false. Oh, wait. P
well, the N is 100. So we got to do a slight calculation. The N is 100. What's the P?
The P is 0.25.
0.25.
Oh, so this is like a formula, pretty much. Oh, you cool.
Yeah. So you got to run the calculation, I guess, to see if you can use this.
Oh.
So what we're talking about is 1 minus 0.25, which is 0.75 times 100 would be 75, and that is greater than 10.
Yeah.
And then there is N times P hat. What is N times P hat?
That would be
that'd be 10, right?
Yeah, 1, 2, yeah. 2 decimal places, 10.
Okay, so that's equal to 10. So yes, I think that it meets the requirements.
Nice. Thanks a ton. That helps a lot. The last quiz I had to do it several times, even though I got it right on the second answer, but I was still, like kind of sitting on the fence with it. But it makes sense then that you actually have to plug in the values into the requirement to see if it's satisfied.
Yeah. Hypothesis.
All right, so I gotta do the same thing here. Okay, NP10.
Hypothesis test for one proportion.
Wait, it's the same requirement though. Oh no. The first one was
sure?
P hat. The second one is just P. So n times p here will be 25. And 25 is greater than 10, and then n1 minus p. So 1 minus 0.25 be 0.75. 0.75 times 100. Yeah, I think
You
it's
think
met.
it's okay? I was just looking for that formula. Where did you find that at?
It's just remember the remember thing that you showed me, the one you just talked about. It's just right below the requirement. The next sentence is a requirement for hypothesis test. So the first sentence was requirement for confidence interval, and then right after that there's another sentence.
I see. Okay.
Cool. And I think the only difference is they switch p hat with p.
Yeah, they did. That's about the only difference.
Yeah.
Okay, great. So number 6, use the following information for the next 5 questions. Study of first-degree murder trials was conducted in another state. A random sample of 6 people on the trial for first-degree murder was taken. Of these, 45 of the students were found guilty. So find p hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in the state. Find p hat, the point estimate of the proportion. So we need to find the p hat.
So
the first degree murder defense were found guilty in the state.
You know, it should be p. 60 people and 45 of them. Wouldn't it be 45? Nope. Let me look for that formula again. Estimate.
We're looking for confidence interval.
Yeah, we're looking for the point estimate, and I'm sure they'll ask for the confidence interval, but they probably want a point estimate. Point estimate for p is p hat, according to the note.
Point estimate for p is p hat.
Yeah, I'll share my screen real quick.
Yeah, under 2.2, I think I see what you're talking about.
Yeah.
The point estimate for p is p hat. P hat. And we add and subtract a certain number of standard deviations from this value. You can call the same patterns done there for one portion population. The proportion of first degree murder defense were found guilty in the state ran to 3 decimals. P hat equals x over n.
So 45 divided by 60, right? Because n is the sample size, and then p hat will be 45. So
yeah, 45 divided by 60. That'd be 0.75. That's what you said right at the beginning. I should listen to you more often.
That's okay. It's so like maybe this might, if they ask for 3 decimal places and it's 0, you think the system still mark you down if if you don't put a 0 there, like, because right now it's 0.750, right? But if we don't put a 0 there, would it mark us down?
Yes, I think they will.
Okay. Just it's good to know. This is more for head. Like, I just wanted to make sure so that I don't do that.
Yeah, I think that it will. So 0.750 is what you want to put.
Okay.
So now we need to create a 95% confidence interval for the true true proportion of first-degree murder trials in the state that where there the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. For the true proportion of first-degree murder trials in the state.
So which one do we use the we're going to use the one proportion, right? One sample. This is from the categorical data analysis hat.
Yeah. So it looks like the formula we'd want to use is under the 2.2 of our lesson.
Okay. I think they have that formula plugged into the app. I think I could be wrong because I'm looking at the app right now.
Okay.
This one right here.
So P hat. Man, I wish I had a notebook on me.
So this one, can you see my screen?
Yes.
Okay. So I think they put the formulas in here because it got P hat. So let me change this. Maybe I might, if this P hat matches what we calculated, then this formula should be the similar thing here. So our population size was 60, right?
Yeah.
All right. 0.750. So it is working fine. Our N is 60. What confidence interval were we working with?
95.
95, so that's good. What the heck? How is the null hypothesis to 0.70?
We are looking for a 95%. Let's see what we're traveling in this state where the verdict is guilty. Okay, your answers. So we're looking for guilty. So they're either innocent or guilty. So I think the null hypothesis would be, heck, I don't know.
Yeah.
That doesn't really apply. I don't think that the null hypothesis and type of test are going to matter.
Okay.
So what you should do to test that is try changing the type of test to less than or not equal to, and see if the data points we care about change.
Okay. So right now we're looking at P hat and our confidence interval, right?
And p-value.
And p-value right there. Okay. Less than p-value change with less than equal to p-value change. So p-value change on all of them. Should I clear this null hypothesis out greater than this one? Let me see if this would change to 20. Ooh.
The mean. Try changing the null hypothesis to a different value.
Yeah, let's see, like 0.5?
Sure.
Oh, 0.5 or 0.05? I got that confused. Okay.
Did that change our confidence interval?
Let me see. Control Z. No, it didn't.
Okay, so we got the lower bounds and upper bounds.
Yeah, these are not changing at all. So I think the lower and upper bound, the confidence interval should be good.
Okay. Lower bound would be 0.640. Upper bound is 0.860.
Oh, wait. So wait. Okay, I'll lower. Did we get number 7? I forgot.
No, we're still figuring that out, but we do know 8 and 9.
Oh, okay. Okay.
Determine the margin of error. You have a margin of error there?
No. Let me see. The margin of error formula. I know this is confidence interval. It should be here. 1 second. Margin of error 95%.
0.860. The margin of error. Is the margin of error just the difference between the lower and upper?
That's what I'm thinking. Remember on one of the last homework, you did something to the lower and upper confidence interval. I still have the formula plugged into my value. You got, I think, the absolute values. You did some kind of formula thing that worked well, but you did use the confidence interval, the lower and upper limit. You use it and did some absolute value, something that gave us the margin of error.
Okay. Yeah, I remember doing that. So we're looking for the absolute value of the lower confidence interval minus the absolute value of the upper confidence interval. So we are supposed to round to 3 decimal places. So I think number 7 is 0.566.
Okay. And that was the absolute value of the lower minus higher, right?
Right, because they're both negative. And so what I'm looking for is how far apart the lower and upper confidence intervals are on a number line. So they're 0.566 apart from each other.
Okay.
That's how I calculated that. And since these are negative, the confidence intervals are, it was easier to take the absolute value and just find the distance between them that way. That wouldn't work if you were dealing with two positive numbers or a positive and negative number.
Okay.
So I think 7 is 0.566.
Okay.
Now, number 10.
Number 10.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
I'll go ahead and change it right now and see what happens.
All right.
80.
Wait.
The width, did the width decrease? Let me see. Control Z. Oh, I'll go ahead and get a difference between those two right now.
I'm sorry, I made a mistake. I was working off the wrong data set.
Oh, okay.
I actually think that number 7 is 0.219.
Let me see. Yeah, and just to make sure my formula is running right, 0.2191306. Is that running right?
Yeah.
Okay.
Because you're trying to find how far apart the lower and upper confidence intervals are.
Okay. So let's see. Verse 7.
So we don't care about the p-value, and that's all that's changing. Yeah, we're good.
And then
0.860. Okay. All right, now I'm back up to 10. So what happens when we increase the sample size from 60 to 80?
let me see. I'm trying to get the old value that we had, and then I'll subtract and see what happens. This
17.
Okay, and then I come back here and change it. Change this to 80.
So what I'm finding is that the confidence interval decreases.
Yeah.
Is that what you're getting?
Yeah, I'm just trying to see about how much it decreases by. That's what I'm trying to see.
It decreases very little in this example, only by 0.002.
Yeah, that's just what happened. So it went from 0.219 to 0.217.
Yeah.
So decrease. To conduct a hypothesis test for one proportion, two requirements must be met. Oh, this is the question that I got wrong on on the last group quiz. I could not. I think this was question number 3. It said 1/4, and what is the smallest n can be in both requirements. Still, I could not get this thing right. Like I got everything else right, but this one, and I was so annoyed. So if you know how to work this one, I would love to hear how you did it.
Suppose P equals 1/2. Well, let's see. They're talking about changing n. What's the smallest n can be, and both requirements still be met?
So are you going to use the formula requirements for confidence interval and requirements for hypothesis test, like in question 3 and 4, where we did n times p less than or greater than 10, and then n1 minus p greater than or equal to 10? Is that what it's asking to do here?
Yeah, I think so. So we're going to try and figure out p. P equals 1/2. How small can n be? I wonder if they are still referring to this data up above question 6.
Have we answered 3 questions yet? Because it's use. Dang it, where did I go?
Use it for the next 5 questions. So
next, so that we're still using the same data, right?
5. No, actually, we're not.
We've answered 5 already.
Yep, number 5 questions puts it as number 10.
Oh, so number 11 is a whole different ball game, I guess.
Yeah. So suppose p equals 1/2. What is the smallest n can be, and both requirements still be met?
Let's see. I'm just gonna build that formula and see if that will help me at all. So I'll put it here, and then so n times p is greater than
p equals 1/2.
P. And 1 minus p n times 1 minus p, and then put it times there. All right, and our p is 1/2 equals 1. So, all right, so how small n has to be? Oh, I should probably put this formula in equals this times this. And I can even do goal seek. Once I got it, I should be able to do goal seek here. Equals this. 1 minus this.
Times 5.
And then I'll goal seek and just have it. Where's this goal seek?
Standard deviation of hypothesis.
Whatever.
Don't they have to give us some data? I mean, come on.
So this, I think, this to 10 by changing this.
N can be in
Okay,
both requirements.
the smallest n can be is 20.
Okay, how'd you do that?
So let me share my screen real quick. I had to do go seek. So here and share. Okay, so so what I did was, okay. So in the formula here, this is the first half, it says n times p hat should be greater than or equal to 10. So in this formula right here, I put n times p. And then I came down here in this formula, I said n times 1 minus p. And then I close it. Then I just came here and did goal seek. So what if analysis, goal seek. And then I said set this cell to 10, since I know in order for it to be met, it has to be greater than or equal to 10. So it has to be equal to 10 for me to get the smallest value, and then greater than 10 for me to get the largest value. So set n times p to 10 by changing n, because I want to know the least value n can have. And then I hit OK. And then they work it out to give me 20. And I can change that to 15. 7.5 doesn't, respond to this. And I did it for both of them so that if it works here, it has to work. If it doesn't work in both of them, then I will keep trying it. Let's see, 19.5. 19.5 won't give us, but
Tony gave us 10.
Yeah, but Tony will give us 10. That's how I did it, strictly based off of this. So if this is what they're asking for, then
0.5 n times. Okay, yeah, that makes sense to me. It does. I like it. And number 12 is the same question, but p equals 1/10.
Oh, okay. So I would just stick in 1/10 over there. So number 11 was Tony.
Well, yeah, they're both hypothesis tests.
Okay, so P1/10. So I would just come and do the same thing here, but this time I will change P to equals 1 divided by 10.
0.1.
And then I'll come here and hit goal seek. Let's see, go see. Change. Make this cell equals 10 by changing this cell. 100.
100.
Okay.
Okay.
Using the same formula that I did earlier, I got 100.
Right. Okay, cool.
Which makes sense, because if 11 is equal to 20 and he changed the denominator to 10,
yeah.
Okay.
Yeah, I think it makes sense to me.
2 times 5 is 10, and 5 times 20 is 100. So.
Yeah, it makes sense. So number 13, use the following information for the next 6 questions. Okay, this is the rest of the questions. The water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.05 with the following hypothesis, where null equals 0.6 and hypothesis is less than 0.6. They collect negative data, and this time n equals 80 and x equals 38 indicate a good health. The conditions for conducting a hypothesis test are satisfied. Okay, so we're going to want to use your formula you just did.
Okay.
And so you're going to need to put in for P 0.6.
0.6, okay. 0.6.
And then our sample size, which is 80.
80.
You don't use X, do you?
No.
Okay.
So when I did it, n times p would be 48, and n times 1 minus p would be 32. So the hypothesis tests have been satisfied.
Okay, great. So what is p hat? That's our next question.
Okay, so I will plug in. So I'm using this. Let me share this that way we can come in.
Yeah, we're using the 1 proportion Excel sheet now.
So you can see my screen, right?
Yeah.
Okay. So up here, X was 38. And then N was 80. Oh, N is 80. We're doing a 95 because A is 0.05, right? Or
Yep.
alpha. And then null is greater than or less than 0.06. So 0.06 and less than. Okay. So our data here matches, right?
38, 80.05 .06. Yep, that matches.
Okay. Oh, equal to, sorry, whoopsie.
Oh, also you need to change your P to 0.6, not 0.06.
Oh, okay.
For null hypothesis.
6. The type of test is less than. Okay.
Yes.
All right. So this are the so ignore everything on this. So everything here is like things that I work myself. The one in the boxes are like just as it came from the internet. So
okay.
So they want a p hat. Oh. That's
yeah. I am. Let's see. I'm seeing 0.475.
Yep, that's correct.
475. Okay, find the test statistic.
So that'll be the Z score, right?
I think so. The Z would be the standard deviations.
Yeah, the standard deviations are up here because there's F score, Z score, T score, and what's the other stat thing? Is it standard deviation? So those are the stats. So Z stats, T stats, and F stats or F score. But if they got a different Z score calculation here, wait, the test statistic. I'm pretty sure the test statistic is the Z score.
Do a quick search.
Okay.
Find the test statistic. Value minus mean over standard deviation. Yeah, they're saying it's Z in the book.
Okay. So Z
so minus
here
2.8. So put 2.282.
Yeah, minus 2.282.
All right. So now we're looking for the p-value.
P-value is right there, 0.011.
Yep.
Hi guys.
Hey, Bartholomew.
Well, dude, what time is it over there? Like 6 a.m. in the morning?
4:30 a.m.
Oh my goodness.
Yeah, man. I'm sorry. It's been a crazy week. We didn't mean to do this during the weekday.
Yeah.
Well, good news for you. We're almost done.
Two more questions, then you should be good to go back to bed and get a few more hours in.
Okay.
Okay, so the question is, what is the decision for this test? I have kind of forgotten how to evaluate that.
I think if P is less, reject. If P is, yep, I wrote it down. If P value is less, we reject the null hypothesis. If P value is high, we fail to reject.
Okay, so we reject the whole null hypothesis because P is less than the null.
Than A.
Less than A, that's right. Less than A, which is 0.05. Okay.
And
great. Good
Question
notes.
18 is what really messes with me, like trying to put it in these words. There is insufficient evidence to conclude that water quality in the area has not decreased. And there is sufficient evidence to conclude that there is insufficient evidence to conclude that water quality in the area has decreased. I guess I need to read the initial question to see which one.
Yeah. They want to know if it's decreased, I believe. P is less than 0.6. Hypothesis test. We failed to reject, so there's insufficient evidence to conclude.
We rejected a null hypothesis.
Oh, we did reject? I thought we failed to reject.
So p value was less than a.
Okay, and in that case, we reject the null hypothesis.
Yeah.
Okay. Okay, so there is sufficient evidence.
Okay.
To conclude that water quality in the area has decreased. The last one.
There's sufficient evidence. Okay. Sounds right. All right, Bartholomew, you ready?
Yes, I'm ready.
So number 3 is the middle
Number
one.
3, the middle one. I was thinking the last one.
Wait, what? The symbol for the true population is. Wait a second. Maybe you came the right time. Is it?
I just submitted, and we got most of it right. Let's see. We got question number 7 wrong.
Dang it.
Okay, we got 7 and 3 wrong.
7 and 3. Yeah, that's why Bartholomew was talking about. It should be the last one.
Was he?
Yeah, he just mentioned. He said the last one, which makes sense.
Yeah.
I think I got it wrong the first time. So number 7. Let me see what we did. Oh, the matching.
Okay. So 7, determine margin of error for this. Uh-oh, that was me. that was the one I tried to do. I got that wrong.
It's okay.
So, question 4, true.
Oh,
Question
sorry about
5.
that. So question 4, true. Question 5, true.
Okay, question 6.
6 is 0.750. 7 is 7. We got 7 wrong, so we got to work 7 again. That margin of error thing was driving us nuts.
Okay.
Number 8 is 0.640. Number 9 is 0.860.
860, yeah.
10 is decrease. 11 is 20. 12 is 100. 13 is true. 14 is 0.475. 15 is minus 2.282.
Minus 2.282.
Yep. 16 is 0.011. 17 is reject. And 18 is the last option.
Okay.
And then we'll go back to 17 and look and work through it.
Question 7.
Let me see if there's anything.
Determine margin of error.
Oh. You guys see it? Let me share my screen real quick. I think we can.
I see your screen.
We can.
Oh, now I can't.
Oh, let's see, right there and share. Okay. So right here, this is that lean formula we're looking for.
Okay.
So margin of error equals the z-score times the square root of p 1 minus p over n. So I'm just gonna put it right here. I'll just find, let me see. Let me take this out and just put it right here. Margin of error. Okay, margin of error here. Would it be weird to just build it directly in here, or?
Yeah, well, that's p hat, but either p or p value. I think you would take the p value and not the p hat.
We will. I thought P hat was P at one point. Man, these things are like so tricky. Like you feel
They
like
really are.
you get it somewhere here. Okay, here. This is what I'm thinking. Like P is P, but I don't know if it's just for point estimate. It doesn't work with the margin of error formula. Well, so we could use the value of P and then I will submit, or we could use P hat and I will submit. If that doesn't work, then we'll use the value of P. Which one do we want to give a shot at first?
Okay, sounds good to me.
Which should we go with P hat?
I think we should do p value is what I think.
Okay, so equals z score times square root the square root of
Well, wait, you said p is p hat. That's
yeah.
what it said, right?
Mm-hmm. That's what the note says. So should we go with P?
Let's go with p hat.
P hat. Okay.
You should put, yeah, P hat.
So square root P times, and there's 1 minus P hat close parenthesis divided by n. Close this, enter. All right, that's our margin of error. And I'll stick that in and submit it real quick and we'll see what happens. Give me 1 second. Go to submit. Question number 7. Dang it, we got it wrong.
Flip sake. All right, 3m equals z. Z. Get a couple windows up here. Yeah. This is on me. 3. Where's that? 3? Yeah, there it is. Okay. So m, we don't know m, or z. That is right there. Okay, my turn to share the screen.
Okay.
Okay.
All right, so what I'm going to do is take equals z times.
Wait, how come you have 60 for n?
I'm not sure.
That's question 16. Let's see. Number 7. Wait a second. Oh, that's why I got it wrong. Guys, our formula is correct, but here's what I messed up, okay? The data, your data is correct. When I did it with 38 and 60, but I did number 16 data on number 7. So don't do another calculation. I think our calculation here is correct. I used the wrong data. So let me change my data and have Bartholomew submit, okay?
Okay.
95%.
Does that make sense at all?
Yeah, that makes
Yes.
Yeah, that makes sense. I'm just checking to see what the null would be.
Okay. So 45
61.
and 60. Okay. So Bartholomew?
Okay.
The margin of error you should try should be 0.133.
0.133.
Yeah. Give that a shot and let's see.
What did you put in for your null hypothesis?
The null hypothesis. Oh shoot! Wait. Hey, Bartholomew, don't submit. Dang it. have you submitted yet?
No.
Okay, good. Yeah. Thank you so much, Justin. I totally slipped that. That totally slipped my mind. Did we have a null hypothesis here? I don't think so.
I was just looking to see what the null would be, and I don't know what it would be.
Dang it. And we didn't even have a confidence interval. So I guess we would just plug it in directly. Escape. So I think we should just use the formula like you were about to do earlier and just plug, because the value for P in this case would be for 45.
45 for P?
Yeah, but how the heck do we even get a z-score, huh?
Well, that's what I'm wondering, because we don't know what the null hypothesis is.
Oh, why do they do this?
So I don't know. The P hat?
The P hat will be 45 over 60, which is
45 over 60. Yeah. Well, we're trying to find the margin of error.
And to do that, we need a P. And we need z-score. How are we even going to get a z-score?
We got to come up with a null hypothesis. So the study of first-degree murder trials, a random 60 of these 40. So 45 of the 60 was guilty. Create a 95% confidence interval for the true portion of first-degree murder trials. I might have an Excel sheet for this, maybe.
So then
This may be. Oh, wait. What is it doing? My goodness. Gotta go away now. Okay. Confidence interval. So we need X, we need Z, standard deviation, and we need the sample size. Let's start plugging what we know. We don't know a standard deviation.
no.
Don't know Z. We know this, 45. It doesn't give us anything. We know we're looking for a 95% confidence interval, so our Z would be.
Oh, guys, I totally see what it did there. You see what it did? So we will use the 95% confidence interval on a probability app to get a z-score. Oh, I hate this score sometimes. That's how we get our z-score. We use the probability app to get our z-score.
Okay. Well, we've got the z-score right here.
Okay.
So the z equals that standard deviation. Margin of error. B6. Where does B6 come in? That. Okay. So we need a standard deviation. How do we get that?
Ooh.
Maybe, no, wait. 1.96. Proof out used in percent part of applet. 0.95. I don't really know, guys.
Wait, what was our p value today on number 6?
That was 0.750.
Okay, 0.750. Give me 1 second. I think this might work. Minus
Hey,
1.750.
Yuko, didn't you get an answer for 0.189 one time?
No.
No? Okay, never mind.
1 second. There we go. All right. Okay, Bartholomew, try this number, and if it works, I will explain what I did.
Okay.
Try 0.849.
.849.
Hit enter and see what happens.
Yeah.
Oh, dang it. Wait. I forgot to divide it by the sample size.
I shouldn't already.
Oh, you did it? Okay. Okay. I'm gonna do the next one. When I did the formula earlier, let me explain my method to you guys, because I'm about to submit it again. I will put in my answer and go this time. Can you guys see my screen?
Yep.
Okay. So here's my formula, right? So the z-score of 0.95 is 1.96, right?
Mm-hmm.
If you come here, z-score 1.96 times the square root of 0.750, which is the p-value that we have, which would be right out here, 1 minus p, which is 1 minus 0.750 divided by 60. That's where I messed up. So I didn't include a 60 in here before submitting it, and that's why it was wrong.
Okay. So what you're gonna want to do is divide that whole, yeah,
just like that. Hit
but,
enter,
yeah.
and then stick this in. I'll go ahead and do it right now, and then we should be. I think we should be good. Let me start my quiz again. Sorry, it'll take me a few seconds to copy and paste my answers in real quick, but I'll try to be fast.
I'm gonna do it too.
Okay. Man, this is so tricky. I think I'll just go ahead and do Saturday's homework tonight, since I can kind of understand it right now, so that I don't kind of get stuck. Because now that it's making sense to me, I'm better off.
Yeah. This is very confusing.
It is. Number 6.
Number 4 is true. 5 is true. Bartholomew, did you get all the answers down that we have?
Yes.
Okay.
So let me see. Question number 16. Is it point 111 or 0.333?
Which question number?
16.
Just a second. I'll get to 16 just a second.
Point 0.011.
0
11.
11. Okay. Oh wow. I made it point 111.
Sorry.
Yeah.
And we can review all the answers again before I submit.
11.
Decrease.
That's true.
$14.
So 18 was the last one.
Mm-hmm.
All right, Uko, what'd you get for 7?
On the calculation, got 0.110. And I'm gonna submit real quick so that at least if I get it wrong, you guys can have the chance since it was bad. Yeah.
All right.
1 second. I'm on 17 right now.
Okay.
And I'll just review all my answers real quick since I was running through. Number 3 was the last option. Number 4 was true. Number 5 was true. 6.750. 7.110, which is what I got on a calculator. 8.640. 9.860. 10 decrease. 1120. 1200. 13 true. 14.475. 15 minus 2.282. 16.011. 17 reject. 18 there's sufficient evidence. So go to submit. Yes, submit this thing. I just want to know what's on number 7. Yep, we got it right.
Wait.
So 0.110. If you guys want to kind of build like a sheet on it, let me know. I can review. But it's just literally is that formula, that end formula. I think the only thing that threw us off was to take the 95% and put it into the probability app and use the z-score, which I think they're pretty much the same always. 1.6 something, and then 1.9 something, and if it's 99%, it's higher than those two.
Yeah, nice catch on that standard deviation conversion.
Oh,
that was good. So Bartholomew, you got all that right?
Yes. So the 7 is 0.110.
0.110.
110.
Yeah.
Okay.
Are we all good?
Yes.
Okay.
Sweet.
Awesome.
I'll submit this to the discussion forum.
Okay. And we're meeting on Saturday, right? Same time?
Yeah, what time was that again?
9. I think we met at 9 a.m.
Yeah. You okay with that, Bartholomew?
Okay, yeah.
Okay, we'll do the next week's ones so we don't have to meet so late.
Yes.
All right.
Awesome. You guys have a great night.
Thanks, guys. I'll see you later.
Okay, bye.